So we have completed the binomial distribution. Now let us start the problems on Poisson distribution. But before going to the Poisson distribution, under the three conditions, binomial distribution tends to the Poisson distribution. Right? So here, under the three conditions, what are those conditions here? When the number of trials are indefinitely large, the probability of success is very small, and also the mean of the binomial distribution becomes finite, then the binomial distribution will tend to the Poisson distribution. Now if you see the first problem here, just like the binomial distribution, there if the mean and variance is given, we have to find the probability of some x greater than 1 or x greater than 2 like that. So here also, if a random variable x has a Poisson distribution such that probability of 1 is equal to probability of 2, then find the mean of the distribution, probability of 4, probability of x greater than or equal to 1 and probability of 1 less than x less than 4. Right? So, to find that here, so first consider the probability mass function. What is p of x here for Poisson distribution? E power minus lambda into lambda power x by x factorial, where x equal to 0, 1, 2, so on. Right? Now here it is given that p of 1 is equal to p of 2. The condition is p of 1 equal to p of 2. So p of 1 equal to p of 2 means e power minus lambda, where x equal to 1, lambda power 1 by 1 factorial. P of 2 means here x equal to 2. So e power minus lambda into lambda square by 2 factorial. If you want to simplify here, you just see that e power minus lambda will get cancelled, and lambda power 1 is lambda, 1 factorial is 1, lambda by 1, lambda square by 2 factorial is here 2 into 1. Right? Now here also the lambda can get cancelled. So that implies here lambda equal to 2. So lambda equal to 2 is nothing but the mean of the Poisson distribution is 2 here. Right? So therefore the first bit, right, mean of the Poisson distribution is 2 here. Then when the mean of the Poisson distribution is 2, then what is our probability function here? P of x equal to e power minus 2 into 2 power x by x factorial. But to find probability of 4, x greater than or equal to 1 and 1 less than x less than 4, e power minus lambda is common for every value. So first you find out e power minus 2 value. Right? So e power minus 2 value can be found using calci by pressing shift ln. Then e will display. But here in the power you have a minus symbol. So for that minus symbol you have to use the minus within a bracket symbol in the calci and give the value 2, press equal to. So it is 0.1353. Right? So here clearly I am mentioning the calci operations also. Shift ln within a bracket minus symbol and 2. If you press like this, you will get the value 0.1353. Now to get all the remaining second bit, third bit and fourth bit here, in the calci you just give the equation as 0.1353, open the bracket and give the e power minus 2 value, into again open the bracket, 2 power x, for that lambda power x, close the bracket for the entire numerator, then divided by x factorial. Right? So for factorial you have to use the key shift x inverse. If you use the key shift x inverse, then you will get the factorial symbol. So let us give the equation in the calci here. And I think you know about x, right? So x is given as alpha closed bracket. Okay? Now press calci, we will ask x value. Now what is the second bit you have to find here? Probability of 4. That means probability of 4 means probability of x equal to 4. So e power minus 2 into 2 power 4 by 4 factorial. So it is here 0.0902. So since we have to find probability of 4, so we have to represent the answer in terms of decimals only. So 0.0902. Okay, that is the second bit here. Now what is third bit? Probability of x greater than or equal to 1. Now here x is defined from 0, 1 to so on infinity. So x greater than or equal to 1 means exactly x equal to 1 and more than that means 2, 3 so on, right? So it is highly impossible for us to find all those probabilities. So let us consider the formula 1 minus probability of x less than 1. Why we are taking less than? Because here it is greater than or equal to means x equal to 1 and x equal to 2 onwards. So that's why if you find here 1 minus probability of x equal to 0, it is enough, right? So 1 minus x less than 1 means probability of x equal to 0. So 1 minus, again press the cancel key and give the value 0, right? So here it is 0.1353. It is nothing but this one only. Why? Because 2 power 0 by 0 factorial. 2 power any 0 is 1 and 0 factorial is 1. So 1 minus 0.1353, right? Afterwards you can simplify the answer because in between if you press that again the equation will go off. Then what is the fourth bit we have to find here? Probability of 1 less than x less than 4. Probability of 1 less than x means that x greater than 1. X greater than 1 means x equal to 2, 3, 4 so on. But again here one more condition, x less than 4. So probability of x equal to 2 plus probability of x equal to 3. So probability of x equal to 2 means here e power minus 2 into 2 square by 2 factorial plus e power minus 2 into 2 cube by 3 factorial. Now again press Tab C. It is asking x value, give the value 2, 0.2706. Again press Tab C. It is asking x value, give the value 3, it is 0.1804. Now you can simplify this part here, right? So 0.2706 plus 0.1804 is 0.451. Similarly, what is 1 minus 0.1353 here, third bit? 0.8647. Right? So, probability of x greater than or equal to 1 is 0.8647 and probability of 1 less than x less than 4 is 0.4510. So, definitely the condition will be given. Using that condition only, you can find the value of lambda. Once you got lambda value means clearly you can find the probabilities of random variables. Now see the second problem. If the average number of accidents on any day on a national highway is 1.8, determine the probability that number of accidents are at least 1 and at most 2. So here clearly in the problem it is given average number of accidents. So remember, for the Poisson distribution problems, definitely they will mention the average rate of that particular situation in the problem itself. That means the lambda value is given to you. Whereas in the binomial distribution problems, the probability of success or either the probability of failure will be given. Here directly the average rate of that particular situation is mentioned. That means lambda equal to 1.8. Right? So if you move to the solution here, lambda equal to 1.8, that means the probability function is e power minus 1.8 into 1.8 power x by x factorial for x equal to 0, 1, 2, so on. Right? Now, first find out the e power minus 1.8. So again, use the key shift ln within a bracket minus symbol 1.8 equal to it is 0.1653. Okay. Now what is the first thing you have to find? Determine the probability that the number of accidents are at least 1. At least 1 means here exactly 1 or more than that. So first bit is probability of x greater than or equal to 1. So x greater than or equal to 1 means here x equal to 1, 2, 3 so on. So let us use the formula 1 minus probability of x less than 1. That means 1 minus probability of x equal to 0. So x equal to 0 means here e power minus 1.8 into 1.8 power 0 by 0 factorial. So 1.8 power 0 by 0 factorial is 1 only. So if we write here e power minus 1.8 into 1.8 power 0 by 0 factorial, it is nothing but 1 minus e power minus 1.8. What is 1 minus e power minus 1.8? 0.1653. So 1 minus 0.1653. So that is equal to here 0.8347. That means the probability that the number of accidents are at least 1 is 0.x greater than or equal to 1 is 0.8347. Okay. Now, what is the second bit we have to find here? At most 2 means exactly 2 or less than that. At most means less than or equal to, at least means greater than or equal to. So, probability of x less than or equal to 2 is nothing but here probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Right? So, again for this we have to give the equation in the CALC. So, give the equation as 0.1653, that is e power minus 1.8 into 1.8 power x, lambda power x. So 1.8 power x, close the bracket for the power and for the entire numerator, then divided by x factorial. Now give the equation in the CALC. So for factorial, use the key shift x inverse and press CALC key here. It is asking x value. So probability of x equal to 0, if you give that 0, again the same thing you will get 0.1653. Now again press CALC and give the value 1. You will get the value 0.2975. Plus again press CALC and give the value 2. It is 0.2678. Now add all these three values. So 0.2678 plus 0.2975 plus 0.1653 is equal to 0.7306. So the probability that at most 2 accidents are 0.7306. So remember, always the average means the lambda value is given in the problem. And you have to store the equation in the CALC like this. Now, let us see the next problem here. If 2% of light bulbs are defective, 2% of light bulbs are defective is given, right? And find at least 1 is defective, exactly 7 are defective, probability of 1 less than x less than 8 in a sample of 100. Now, we clearly see the question here, average is not mentioned here. Only the probability of defective is given, that is again it comes under the binomial distribution. But here in the sample of 100 means the sample size is very large. That means there we cannot apply the binomial distribution. Then the binomial distribution in this case tends to the Poisson distribution. So what is the condition to tend to the Poisson distribution here? N is definitely large, right? And probability of success is small here, 2% means P equal to 2% means 0.02. And what is the third condition? Mean of the binomial distribution is finite. That means mean of the binomial is here NP and it becomes the mean of Poisson. That is mean of the Poisson is lambda. So we know the n value, we know the p value. So clearly we can get the lambda value here. So n is given as 100. Right? So if you write down the given data, definitely you will get 1 mark here. So 100 into 0.02. What is this value again here? 2. That means lambda equal to 2. So our probability function for Poisson distribution is e power minus 2 into 2 power x by x factorial for x equal to 0, 1, 2, so on. Now, as usual, find the value of e power minus 2 here. So, use the key shift ln within a bracket minus symbol and 2, it is 0.1353. Now, what is the first thing we have to find? At least 1 is defective. Means exactly 1 is defective or more than that. So, the first bit, probability of x greater than or equal to 1 we have to find. So, x equal to 1 and more than that means you can take any number till infinity. So, 1 minus probability of x less than 1 if you calculate, then it is enough. Why? Because here the probability of entire sample space is equal to 1. So, x equal to 0, 1 to so on infinity is equal to 1 here. And if you simplify that 1 minus of 0, you will get the rest of 1 to infinity. Right? So, 1 minus probability of x equal to 0. So, 1 minus probability of x equal to 0 means e power minus 2 into 2 power 0 by 2 factorial is 1 minus 0.1353, which is equal to 0.8647. So, the probability that at least 1 is defective is 0.8647 here. Okay. Now, what is the second bit we have to calculate? Exactly 7 are defective. So, exactly 7 means only 7 items are defective here. Okay. So, e power minus 2 into 2 power 7 by 7 factorial. Now, this time let us take the equation here. So, e power minus 2 is 0.1353 into 2 power x, close the entire bracket for numerator and divided by x factorial. So, give the equation in the calci. So, for factorial, shift x inverse. Now, press the calci key and give the value 7. So, it is 0.0034. So, probability of exactly 7 defectives is 0.0034. Now, what is the third thing you have to find? Probability of 1 less than x and less than 8. So, 1 less than x means x greater than 1. But till how much? Till less than 8. That means here probability of x equal to 2 plus x equal to 3 plus x equal to 4 plus x equal to 5 plus x equal to 6 plus x equal to 7. So, x less 1 less than x is nothing but x greater than 1 means from more than 1, 2, 3, 4, 5, 6, 7, 8 so on. But again till here less than 8 is there. So, till 7 we have to take. Now, again use the calci. Press the calci key and give the value 2. 0.2706 plus give the value 3.1804 plus give the value 4.0902 plus give the value 5.0361 plus give the value 6.012 plus give the value 7 plus 0.0034. Now if you add all these here, 0.0034 plus 0.012 plus 0.0361 plus 0.0902 plus 0.1804 plus 0.2706 is equal to 0.5927. So, probability of 1 less than x less than 8 is 0.5927. Is it clear?